Yeah. And the more you can work in zeros and ones, the better. All right, so we got to use the ratio test to decide if it converges or diverges, right? I know it's been a while. So you might want I don't know, you might want your flow chart out in front of you. Ratio test. Okay. All right, so to do the ratio test, what has to happen?
You have to do the
you have to put in n plus 1, right?
So that's the first multiply it in 10n.
No, I'm going to leave it the way it is. Okay? So I'm going to put in an n plus 1 anytime there's an n. So 10 to the n, 9 to the n plus 1. And then I have to divide by the n, right? So n, and why am I doing it in a series? I should be doing a limit, huh? So let's do the limit in front. So it's the limit as n approaches infinity, and it's an absolute value in there. So it's n over 10 to the 9 to the n, like that. So you take n plus 1, you divide by n, which we did a whole bunch of times yesterday. So these problems with just ratio tests should be really easy, right? Okay. So what happens at this point?
You cross out.
The n's in the exponent cancel out, okay? Not the n's that are not in the exponent. So this is gone with that. Okay, and I'm left with the limit as n approaches infinity of the absolute value of 10/9 times n plus 1 over n. What do we notice about these exponents here? They're the same. So the limit is just the coefficients in front. So what's my limit on this? It's not 10, it's 10/9. Okay, I'll repeat, Devin. So here's the deal. So what we notice that our exponents are the same. Okay, because our limit is approaching infinity, if my exponents are same, the limit is the coefficient in front. Okay, so this time the coefficient happens to be 10/9. A lot of the times it was 1 that we were working with, but this one's 10/9. Okay, so on ratio test, is that bigger than 1 or smaller than 1? Bigger than 1, isn't it? So does it converge or diverge? It diverges. You need to make sure you understand your chart. Okay? All right, we good with number 1? All right. Let's look at number 2. So I have to do the ratio test again. What do we have to plug in first? N plus 1. So we're going to do this. Oh, we're not doing the sum. Stop writing the sum. All right, so it's the limit as n approaches infinity of the absolute value of n plus 1 to the 9th over 10 to the negative n plus 1. And then I'm supposed to divide by n, but in this case I would probably multiply by the reciprocal. Okay, 9. All right, I probably need to distribute that negative in, right?
Which one?
The one that's in this exponent here. So I'm going to go negative, negative. I'm going to be a little lazy about it. So from there, what's going to happen?
They cross out.
The n's in the exponent cancel, right? Because they're both negative there, so I can get rid of that one. I can get rid of that one. It's really 10 to the negative 1, isn't it? Can't I put that back upstairs? Limit as n approaches infinity. I've got 10. These guys don't cancel because they're not, the n's aren't in the exponent. But what do we notice about the exponent, the highest exponent that's going to be on both of them? They're the same, because if I multiplied that out, I know it's degree 9, so it's going to be degree 9. So all I have to do is I have to look at the coefficients in front. So what do we notice about the coefficient in front? It's 10. It's bigger than 1, so does it converge or diverge? It diverges as well.
So why don't we multiply by... Oh, just kidding.
You okay?
Yeah.
All right. Alright. Let's look at this one. Alright, so what are we supposed to put in? N plus 1. Okay, so we've got the limit as n approaches infinity. Okay. I'm doing absolute value. Do I really need to mess with this -1 thing? No. Okay, so I'm going to go 9/5 to the n plus 1 over n plus 1 squared. And I'm going to divide by the n, or I'm going to multiply by the reciprocal, which I'm just going to, I know it's a weird fraction, we're just going to leave it like that. Alright, what happens next? The n exponent cancels. And then I'm going to rewrite it as the limit as n approaches infinity of 9/5 times n squared over n plus 1 squared. What happens now? What do you notice about the exponent on the ends? It's the same. So what's the limit? 9/5, which is still greater than 1. And when it's greater than 1, what happens? Diverges. I'm sorry all of those came out diverges, because that might not happen on the test. What if I tweaked that problem just a little bit and I said it was 5/9 instead of 9/5? What would happen for 5/9?
Oh,
It's less than 1, so that would make it do what? That would make it converge. So make sure you're prepared for the converge, because there's no guarantee I'll do diverges. Yes, Alexis?
How do you know when it's inconclusive? Or is that even meaningful?
I don't know that I would put one on the test. Let's see. It says that inconclusive is when it equals 1.
Okay.
Okay? For both ratio and root. Okay? Yeah, and it should be on your flow chart. Okay, and you get to use your flow. You'll get a flow chart for the test. Okay, are we good? That's right. It's a good Christmas present. All right, let's look at the root tests. So we got a couple of root test problems here. You're guaranteed to see at least one straight ratio and one straight root. I might mix it up and do a couple, okay, because they are pretty easy. We'll see how I feel when I write the test tonight. So for the root test, remember we have to do the nth root of it, or we just were raising it to the 1 over n power, right? And you have to look at the limit, just like we do on the ratio test, of the 6n over 5n plus 1 to the n to the 1 over n power. Or to the nth root of it, your choice. Okay, what happens with these guys? They cancel, right? So now I'm down to the limit as n approaches infinity of 6n over 5n plus 1. What do we notice about the exponents? They're the same, so what does that mean we do for the limit? Coefficients in front. So is it bigger than 1 or less than 1? Bigger than 1, so does it converge or diverge? It diverges again. The good news on ratio and root is they act the same way, whereas like the geometric and the p-series are kind of flipped, right? So the ratio and the root act the same. Yes, Alexis?
Did you get the 1 over n?
The 1 over n. This is part of the root test. For the root test, we have to take the nth root of it, which is the same as something to the 1 over n power. Okay? So I just automatically go to 1 over n. Alright, looking at this one. So, we've got to do the root test. So I'm going to do the limit as n approaches infinity. I'm going to take my function, and what do I need to do to it for the root test? Take it to the 1 over n, or take the nth root of it. Alright, what happens with this right here? Cancel. So I've got the limit as n approaches infinity of 8n plus 1 over 3n minus 1. What do we notice about the exponents? They're the same. So we just take the coefficients in front. So my limit is 8/3. Is that bigger than 1 or smaller than 1? Again, very poor examples. I really should have had one in there that converged. Okay.
What would we do if the exponents weren't the same?
If the exponents weren't the same, okay, so good question. If the exponent on the top is bigger, right? The top would grow faster, so it would go to infinity. If the exponent on the bottom is bigger, right? And I put infinity in the denominator, isn't that the one that goes to 0? Okay. So we do know what to do with them. It's just they aren't typically seen in this problem. Okay. All right, are we good with 5? So then there were 5 problems out of the book. All right. And I gave you some special instructions on some of them. All right. I think the first ones were in the review. Okay. So this one was, so I gave you some even ones. Big hint, I'd probably look at the corresponding odd ones when I was studying. Okay. All right. So what we're going to do is we're going to find the Maclaurin series for the function. We need to use the table of power series for elementary functions. So here's what you need to do. I need you guys to all pull your power series table up on your Chromebooks. So everybody get your power series table in front of you on your Chromebook. I'm going to give you 30 seconds to do that.
A Christmas present?
No, not the Christmas present. I want the one that's on the Chromebook. The new one, right? I did it online because it's on, whatchamacallit. It's also in your book. Everybody find it? Okay. So, we're going to... Alright, so first of all, we need to write out the cosine. So you guys tell me, what is the cosine of x expand to?
1 minus x squared over 2 factorial
Mm-hmm.
x to the 4th over 4 factorial
Mm-hmm.
x to the 6th over 6
Plus x to the 6th over 6
factorial.
factorial plus dot dot dot. Okay? What I am going to do now is I need to adjust it to make it look like this. So to adjust it, I'm going to substitute in a 4x anytime there's an x. So it would be 1 minus 4x squared over 2 factorial plus 4x to the 4th over 4 factorial plus 4x to the 6th over 6 factorial plus dot dot dot. So let's pretend that's not our multiple choice answer if it was multiple choice. Okay, we saw one yesterday where it didn't simplify, but it could. So let's try to simplify it. What is 4 squared?
16.
16x squared over 2. Okay. Plus, what's 4 to the 4th? You all have calculators. By the way, today, whatchamacallit, just so you're aware of this, math analysis started trig, so they threw all the calculators back to degree mode. So you'll have to change it to radian if you need trig.
256.
256 x to the 4th over 4 factorial. Okay. What's 4 factorial?
Is it 256? No, it's not.
It's not 256. It's 20. Is it 24? Okay. Okay, let's go one more. What's 4 to the 6th power? 4096. And what's 6 factorial?
It's a number like.
Is it 720? Is that right?
Yes.
Yep. Okay. Now, let's pretend that's not our answer. Let's pretend it could go further, because all 3 of these could be good answers. So 1 minus, I know that's 8x squared. How many times does 24 go into 256? I'm going to guess it goes in nicely. Help me out. 32 over 3. Okay, and then what does this other one reduce to? 256 over 45. Awesome. Dot, dot, dot. So the point of that problem was making sure you explicitly had to use the table. Could you have derived it without the table? Absolutely. Okay. But this was make sure you're using the table for it. Yes, Devin?
So, since the table skips the 3 and 5?
Yep.
That's this one.
Yep.
For this problem only, but if there was a different problem, did it say to use the table, we would have to do 3 and 5.
If they had, if it was part of the function, yes. So look at the table again. Look at E. E goes in order, right? It goes,
Okay, yeah.
and now look at sine. Sine does the odds, doesn't it?
Mm-hmm.
Yeah. So for this test, I'm gonna let you use the table, but for the AP test, I'd make sure I'd know E, sine, and cosine. And we've been working with them enough that the pattern, you hopefully can recognize the pattern enough. Okay. All right, we good with 24? All right. Let's look at 38. So 38 wants us to use the table. Remember how we did this multiplication thing? Okay. So we basically have to set up a multiplication problem with these two things, the expansion of these two. How many non-zero terms does it say to do? 4. So I've got to get 4 non-zero terms. You can pretty much ignore the rest of the instructions. Okay, it says multiply, divide. I'm not worried about using the graphing utility part. Okay. So in your table, tell me what is the expansion for E?
1 plus
1 plus x squared over, no, plus x squared over 2 vector.
Good. Is it over factorial or just 2? It's factorial. Okay, so but 2 factorial is 2 plus what?
X cubed over 3 factorial, that's 6, right?
Yep.
And then
Oh, let's go one more.
x to the 4th, that's like, what, 12?
No. It's 24, isn't it?
24
There's actually a typo in the answer book.
plus dot dot dot.
They went to a 4th power instead of a cube. Okay. So plus dot dot dot, right?
Yeah.
And then I'm going to write my other one underneath. So what is the cosine expansion?
1 minus x squared over 2
1 minus x squared over 2
factorial
factorial, which is just 2. And then what's after that?
plus x to the 4th over 4 factorial.
So 24 plus dot dot dot. So all I did, this was the E, right?
Okay.
E to the x, and this is the cosine x, but I'm setting it up like an old school multiplication problem. Okay, remember how we did that? Right? Like elementary school multiplication. So I'm going to start by taking this one and I'm going to multiply it by everything. Instead of multiplying from the right, we multiply starting from the left. Okay? And I've got to try to get to 4 non-zero terms. Alright, so I'm going to multiply 1 by everything, so basically I'm writing that down, right? X plus x squared over 2 plus x cubed over 6 plus x to the 4th over... That's probably more than enough, right? That's going to get us 4 non-zero. Alright, next I'm going to go to my x squared and see how far that gets me to my 4... I don't want red, I want something different. Let's go blue. Okay, so I'm now going to do this one times all of them. So what's negative x squared times 1? Negative x squared over... That's going to knock that term out, isn't it? Okay. So what is negative x squared times x? I'm taking this and I'm multiplying it by everything in the other one. Negative x cubed over 2. Okay. And then let's see. Let's go one more here. What's... Oh, wait, doesn't it... It skips one, doesn't it? It would go x to the... So negative x to the 5th over... Let's write it down because we might need it. We don't know what's going to happen with this other one here. Okay, if it's going to knock it out or not. Alright, I'm going to go to the next one. Oop, not the slide. I want to go to the pen. Alright, so now we're going to look at this one and distribute it. So let's see, I'm going to do 1 times x to the 4th. What's that going to be? X to the 4th over... And that's really all I need to do, right? I guess I could do the 5th power if I wanted to. I could do x to the 5th over 24. Okay, now we need to add those up. Obviously, I ran out of space. I should have written much smaller. So I have to get to 4 non-zero terms. I'm going to write my answer over here. Okay? So my first non-zero term is 1. Okay? My next non-zero term is x. These guys knock out, so I've got to go to the cubes. Let's see, I could make that over 6, couldn't I? Wouldn't it be 3/6? They don't knock out. So what's x cubed over 6 minus 3 over 6? Negative, go ahead and grab a Chromebook, okay? Negative 2 over 6 or 1/3 x cubed. I need one more term, right? So 1/24 over 1/24 is going to be 2/24 x to the 4th plus dot dot dot. Did you fill out a paper the other day or no? No? Okay. Let's give you a paper. Okay, you can leave your bag in here. And go ahead and take your Chromebook out to the pod. I will put your first name in as the password. Okay? And you can have a calculator. Alright, everybody got it? I gotta set a password here and then I'll be right back to where you guys are at. Yep. Yep. Take the pass.
Pull my hair?
Make sure.
It's irritating.
What?
Okay. Alright. Let's keep going. We good with that one now? Yeah.
When you were multiplying the negative x squared over 2,
Uh-huh.
why did you skip multiplying x squared over 2 when you went to x cubed?
Okay. 1. So why did I skip? Oh, I skipped this one, didn't I?
Yeah.
I don't know why I did that. I shouldn't have. You're right. So our fourth term is wrong, isn't it? Okay. Good catch. So we would have negative x to the 4th over 4, right? So if I put that in there as 24ths, let's see, it would be 6 over 24. So how's that going to change it? So I've got 2 negative 4 over 24, right? Is that right? Good catch, Alec.
So it's wrong?
I missed multiplying one of them. I missed multiplying this one. So you just gotta fix it. It happens. We're only human, right? Thanks. Alright. So, last 3, all I really wanted you to do is focus on creating the general term, okay? Are we good? Can I keep going on that one? Alright, so these ones, it's really focus on creating the general term of the power series. So I want you to focus on getting the summation, okay? So in order to get the summation, remember you need the a sub 1 and the r, right? Because it's to the n. So I have to create, remember it has the formula a sub 1 over 1 minus r. I've got to create that out of what I'm given. So we're going to practice that a few times. Okay. So I guess it's just, our formula is just a, isn't it? Not a sub 1, but a. Doesn't matter. Same thing. Same thing. All right. So I've got the minus, but what do I need this equal to? What do I need to get it equal to? 1. So how do I get it equal to 1?
Minus 5.
Divide by 5. So you've got 4/5 over 1 minus 1/5 x. Okay, that's enough to put it into our summation formula. So I've got the sum as n equals 0 to infinity. What's my first term, or my a? 4/5. And then what's my ratio? 1/5 x to the n power. But that's not what the answer is going to look like. We're going to do the fancy algebra here. I'm going to distribute that n in. So I've got 4/5, and these are both to the first power, x to the n over 5 to the n. And I've still got this thing out front. Whenever my bases are the same and we're multiplying, what do we do with the exponents? We add them. So we got 5 to the n plus 1 That is what the general term of the series would look like. All right, we good with 2? All right, I'm going to go to 4. Okay, I have to create that a over 1 minus r thing again. What am I missing?
A 1, right? No. Oh, negative.
I'm missing the negative, so I have to create a negative. I make a double negative, right? All right, and so now let's put it in our summation. So n equals 0 to infinity. What's your first term or your a? 1. And then what's my ratio? Negative x, right? Which is really negative 1x, isn't it? To the n power. It might be written like that, but likely they're going to probably do this. They're probably going to say negative 1 to the n, x to the n. That's the answer. That's what I'm looking. Yeah. Today's are far easier than what we were doing yesterday, right? No. But it'll be a part of it. Okay. Won't work. I don't know. This is 10 questions. Yesterday's was 16, so it won't be as many as yesterday's, but I'm not going to... There's a total of 26. I'm not putting all 26 on, right? It'll probably be around, 14, 15 questions. All right. Power series again. All I want to do is... I'm not going to worry about the interval of convergence on this one. We did enough of those yesterday. All I want to do is create the general term. Okay, so let's try that with this one. So... I've got to still get it into that a over 1 minus r, but before that, notice I have a c value, right? So I have to create an x plus 2 with that, but there's already a negative in front. So technically I distribute, and I have to figure out what I would put in that blank to make 5. Good. And then that's what gets replaced in the denominator. So I really have 4 over 7 minus x plus 2. All right, what does this still need to be equal to? 1. So what do I have to do to get it equal to 1? Divide everything by 7. So I have 4 sevenths over 1 minus 1/7 x plus 2. All right, let's put it in I'm going to put my summation formula in this box. So the sum as n equals 0 to infinity, what's your first term? 4 sevenths. And then your ratio is 1/7 x plus 2 to the n power. Then we're going to distribute the n in, right? I don't really need the 1 anymore. 0 to infinity, 4 over 7. I've got x plus 2 to the n over 7 to the n. When my bases are the same, what do I do with my exponents? Add. So our denominator exponent would convert to 7 to the n plus 1, and we've got 4 times x plus 2 to the n. All right, and that's it, right? That's it. Okay, so you have a lot of extra time today. You should be practicing these again and studying and using that time, right? Also, don't forget, C's Candy is due by next Friday. I'm waiting.